In 2018, one of the biggest tech companies in the world had to scrap a secret AI project. They had spent years building an artificial intelligence to screen job applicants and automatically pick the best candidates. The goal was to make hiring perfectly objective. The result? The AI taught itself that male candidates were preferable.
What?
It systematically penalized resumes that included the word women's, as in women's chess club captain, and downgraded graduates of 2 all-women's colleges.
The technology thought, oh, Amazon doesn't like any resume that has the word women's in it. Women's, captain of a women's chess club, captain of a women's soccer team, and all women's university, because the company has hired so many male engineers or software developers, data scientists, and so forth, that clearly the unsuccessful candidates are the ones who also would have this word women's in it.
This brilliant, expensive AI didn't just fail, it actively learned to be biased. This wasn't a one-off glitch. We see stories like this all the time. AI loan applications that deny people based on their zip code. Facial recognition that works perfectly on one group of people and fails on another. Self-driving cars that get confused by a piece of tape on a stop sign. We're told that AI is the future, that it's this incredibly intelligent, almost magical technology. So why do these systems, built by some of the smartest people on the planet, fail so spectacularly?
That's sad.
The answer has less to do with science fiction and everything to do with the nuts and bolts engineering of making AI work in the real world. And understanding that process reveals the critical, often invisible line between an AI that helps humanity and one that actively harms it.
Before we can understand why AI breaks, we need to understand the kind of AI we're talking about. This isn't the sentient robot from the movies. This is applied AI, the silent partner in your digital life. When Netflix guesses with uncanny accuracy that you, a fan of gritty crime dramas, might also enjoy a dark Scandinavian noir, that's applied AI. When your bank sends you a text message asking if you really just spent $80 on novelty socks from a website in another country, that's an applied AI fraud detection system saving you from a headache. It's the Spotify algorithm that builds your Discover Weekly playlist, the Google Maps feature that reroutes you around a traffic jam, and the spam filter that keeps your inbox clean. These systems aren't trying to become self-aware. They are highly specialized tools designed to do one specific job really, really well. They work by learning patterns from massive amounts of data. The Netflix AI has seen what millions of other crime drama fans watch next. The bank's AI has learned the subtle patterns of fraudulent transactions versus your normal spending habits. When they work, they are seamless, almost invisible. But for an AI to move from a data scientist computer into your life, it has to be more than just clever. It needs to be built on 2 foundational pillars that are almost always overlooked. And it's the weakness in these pillars that causes billion-dollar projects to crumble.
Imagine you're building a bridge. You wouldn't just design it to look good. You would engineer it to be reliable, meaning it can handle traffic every single day without any issues. And you would engineer it to be safe, meaning it absolutely will not collapse under stress, even during an earthquake. AI systems need the exact same engineering discipline. Reliability is the first pillar. A reliable AI does what it's supposed to do consistently. Think about your GPS. If it gave you the right directions 95% of the time, but 5% of the time it randomly told you to drive into a lake, you wouldn't call it reliable. You'd throw it out the window.
Being thrown out the window?
A reliable product recommendation engine has to consistently suggest things you might actually buy. A reliable manufacturing AI has to accurately predict machine failures without constantly crying wolf. But reliability alone isn't enough. That brings us to the second, even more important pillar: safety. A safe AI doesn't cause unintended harm. The AI hiring tool we talked about at the beginning might have been reliable. It consistently picked candidates it thought were good, but it was fundamentally unsafe because it caused social harm by discriminating. An AI that approves someone for a loan is a high-stakes decision. If that AI is biased against certain neighborhoods, it isn't just an inaccurate program. It's an unsafe tool that perpetuates inequality. A self-driving car needs to be more than just reliable at getting from point A to point B. It must be safe, meaning it has safeguards to avoid causing accidents, even in weird, unexpected situations. Most AI projects that fail don't fail because the algorithm isn't smart enough. They fail because they weren't engineered to be reliable and safe from the very beginning. And that engineering process doesn't start with code. It starts with the one thing that gives AI all its power: the data. There's a classic saying in computer science: garbage in, garbage out. With AI, this principle is supercharged. An AI model is, at its core, a learning machine. It learns everything it knows from the data you feed it. If you feed it garbage, it will become an expert in garbage. This is the source of so many AI failures. Let's go back to that bias hiring tool. The company trained its AI by showing it the company's own hiring data from the past 10 years. But because the tech industry has historically been male-dominated, that historical data was already biased. The AI didn't invent a new bias, it just learned the existing one perfectly and amplified it. The data it was fed was a skewed reflection of reality, so the AI developed a skewed worldview. This is why data quality is everything. It's not just about having a lot of data, it's about having the right data. Is it clean? Is it accurate? And most importantly, is it representative of the world the AI will actually operate in? A famous example of this was with early facial recognition systems. Many were trained on datasets that overwhelmingly featured images of light-skinned males. The result? The systems were incredibly accurate at identifying white men, but had shockingly high error rates when trying to identify women, particularly women of color. The data wasn't representative, so the AI was unreliable and unsafe for a huge portion of the population. Getting the data right is the most critical and difficult part of building an AI. But let's say you do it. You have a perfect, clean, and representative dataset. The next step is to choose your AI brain, your model. And the temptation here is to grab the biggest, most complex model you can find. But as you'll see, sometimes the smartest choice is actually the simplest one. The world of AI is full of incredibly complex models called deep neural networks, the kind that power things like ChatGPT and image generators. They can achieve amazing results, but they have a huge problem.
Aw, come on!
They are often black boxes. This means that even the engineers who built them don't fully understand why they make a specific decision. The data goes in one end, a decision comes out the other. And the process in the middle is a tangled web of millions of mathematical calculations that are almost impossible for a human to interpret. Now, if you're building an AI to recommend movies, a black box is probably fine. If it recommends a bad movie, who cares?
Who cares?
But what if you're building an AI to help a doctor diagnose cancer from a medical scan? If the AI says, this patient has cancer, the doctor's next question will be, why? What did you see in the scan that led you to that conclusion? If the AI's only answer is, because my mathematical calculation said so, that's not good enough. You can't trust it. It's a medical black box. And that's terrifying.
I am so scared.
This is why there's a huge movement in AI towards explainable AI, or XAI. These are techniques that allow us to peek inside the black box and understand the why behind an AI's decision. An explainable medical AI could highlight the exact pixels in a scan that it found suspicious, allowing the doctor to use their own expertise to confirm the finding. It turns the AI from a mysterious oracle into a trustworthy co-pilot. Choosing a simpler, more explainable model over a complex black box is often the key to building a safe and reliable system, especially when the stakes are high. But even a perfectly designed, explainable AI trained on perfect data isn't safe forever. Because once you release it into the real world, a slow, silent process of decay begins.
An AI model is a snapshot.
Yeah, it is.
It's a reflection of the world as it existed in the data it was trained on. But the world doesn't stand still. It changes. And when the world changes, the AI snapshot becomes outdated. This is called model drift, and it's a silent killer of AI projects. There are two main types. The first is data drift. This is when the input data starts to look different. Imagine an AI trained before 2020 to forecast sales for a clothing company. It learned that sales of formal wear and business suits were strong and predictable. Then the pandemic hits. Suddenly, everyone is working from home. Sales of sweatpants skyrocket and suit sales plummet. The real-world data has completely changed. The pre-2020 AI model, which knows nothing about this new reality, is now completely useless. Its predictions would be garbage.
You know all this is pointless, don't you?
The second type is concept drift. This is where the very meaning of a pattern changes. Think about an AI that detects email spam. It learns that emails with lots of exclamation points and mentions of free money are probably spam. But spammers are clever. They adapt. They start using new phrases, more sophisticated language. The concept of what spam looks like has drifted. The old AI, still looking for the old patterns, starts missing the new spam emails. This is why applied AI is never set it and forget it. Good AI systems have continuous monitoring. They're constantly watching for drift, alerting engineers when the model's performance starts to degrade. When that happens, the model needs to be retrained with new, fresh data that reflects the new reality. It's like a software update for the AI's brain. This monitoring can catch a model that's going stale. But what happens in a split-second decision where the stakes are life and death? And the AI just isn't sure. You can't just hope for the best, you need the ultimate safety net. For the most critical decisions, full automation is often too dangerous.
That's dangerous.
That's where you design a human-in-the-loop system. This isn't about replacing humans, but augmenting them. The AI acts as an incredibly powerful assistant, but a human expert makes the final call. We see this in medicine, where an AI might scan thousands of medical images and flag the 5 most likely to contain a tumor, leaving it to a trained radiologist to make the final diagnosis. The AI does the heavy lifting, and the human provides the crucial final judgment and context. This approach is also used to handle edge cases. A content moderation AI might be 99% confident that a video violates a policy and can take it down automatically. But what about a video where it's only 60% confident? Instead of guessing, the system can automatically flag that video and send it to a human moderator for review. This combines the speed of AI with the nuance of human judgment, creating a system that is both efficient and safe. This human-AI partnership is one of the most powerful models for applied AI. It recognizes that machines are good at processing massive amounts of data and spotting patterns, while humans excel at context, ethics, and common sense reasoning. By building these safety nets, from human oversight to robust monitoring and a focus on explainability, we can start to create AI that we can actually depend on. The journey of applied AI, from a wild idea to a tool that shapes our world, is far more complex than just writing a clever algorithm. It's a journey of discipline. It starts by deeply understanding the problem you're trying to solve.
What you gotta understand, son.
It's built on a foundation of clean, fair, and representative data. It requires choosing not just the most powerful tool, but the most understandable one. And it depends on constant vigilance, monitoring for when the world changes and the AI needs to change with it. The AI failures that make headlines aren't failures of technology as much as they are failures of process. They are the result of building a complex machine without a blueprint, a safety manual, or an emergency brake. Building AI that is reliable and safe isn't about slowing down innovation. It's about ensuring our innovations are worthy of our trust. It's about treating the creation of artificial intelligence with the same care and responsibility we would use to build a bridge. Something designed not just to be brilliant, but to be strong, dependable, and to safely carry us into the future.
Thanks for watching. If you found this breakdown interesting, consider subscribing for more deep dives into the technology that shapes our world. See you in the next one.